Hello everyone. In this video, I'm gonna show you how to model a truss for your roof in Sap2000. To do that, first you need to click on New Model. So by clicking on that, there are different options here. And also you can choose your units. So it is better to set the unit according to your calculation. Otherwise, you can change the units anytime during the modeling. So for now, we can change it to kilonewton and meter. And it depends on your truss, if it is a complicated truss or it is a simple truss that you can find it in a pre-model. So what I suggest you to try to make your truss with 2D trusses, which means that it is plain truss, not a state truss, which is what we want to design. So by clicking on this, it brings an option for you. So as you can see, we have three types of pre-made trusses: slope truss, vertical truss, and pratt truss. So if your truss is one of these, you can easily create it by just giving a number for the dimension of your truss here, and the software will make the truss for you immediately. So to know that what is L1, L2, H1, H3, H2, N1, and N2, you can easily just click on parametric definitions that it shows you different parameters dimensions. So for your truss, you can define L1 and L2, H1, H2, and H3. So based on your model, you can change these dimensions and create your model. So after deciding about your truss, if your truss is very similar to this, however, like there is a small difference. For example, instead of this bracing going upward, it can be going downward, the other direction. So what I suggest is just to create it using this pre-made truss, and then you can select different members and change it to what you want afterwards. For example, if I select these and click on delete on my keyboard, it erases the members that we don't want them. And instead, you can use the toolbar and use the draw frame. And here you can see we have different options. So for this one, because it is a truss member, we want pinned, and we haven't decided about the section, so we leave it as it is. And afterwards, we can assign what section we like to those members. So for now, just leave it as it is. And now you can just click on wherever you want to create those members that was different from your design. So as you can see, I made my own truss using the draw frame. So now we created the truss for now, and as you can see, automatically it creates the supports for you, one pin support and one roller, and it is determinate because we have two support reactions here and one here. So we have three support reactions which are not concurrent and are not they're not concurrent or they're not parallel. So it is determinate and we are able to design it. The next step is to go to define, and what you need to do is to define your load patterns. So what loading we have? We have dead load, live load, and wind load that we want to consider for designing the truss. As I said before, for earthquake, we will apply it at the supports, which is on top of the columns. So we don't need to apply it at the on the truss. So what we need to apply is dead, live, and wind. So as you can see, it is, the dead load is already defined here, and the self-weight multiplier is defined as 1, which means it will consider the self-weight of the members as dead load. So as I told you, because we want to get agreement between our hand calculation and the software, so we ignore the self-weight in this stage. And by clicking modify load pattern, it just changes the load pattern that you have already defined. Now we want to define live load, and you can choose type as live. And again, you don't need to define self-weight multiplier. This self-weight multiplier, if you want to consider, that would be 1 for dead load and 0 for the rest of load patterns. So we are not going to consider self-weight as a live load. We only consider it as a dead load. So it will be 0. And now we can add new load pattern. The other load is the wind load. So what we are going to do is we are not going to define it as a wind load here because we don't have any area that we can define. We can let the software define it for us or calculate it for us. So we want to enter the wind load manually as a point load. So what we are going to do is we define the wind load as others or type other. And so as you can see, we have defined all loading that we have in our structure. Now by clicking OK, we have created those load patterns. Again, we go to define, and you don't need to be worried about load cases because as you can see, the default of the software is linear static, and it is what we want to design our determinate structure. So we are not being worried about that. So next, we are going to define the load combination. Here we define our load combinations or combinations of actions based on a standard. So what you need to do is to open this standard 1170.0, which is the general part. And from there, you will see different load patterns. And we are going to consider the string limited state, which is ultimate limited state that we are going to consider for our design. What I suggest is to define your load combination name as what it is. For example, one of the load combination is 1.35 dead load. So I name it as 1.35G because that would be easier later on after analyzing to find this specific load combination. Now I define, because that would be 1.35 times dead load. So I have dead load and the multiplier or the scale factor is 1.35. And I need to add it. It is the only load in this load combination. So I click OK and define the next one, which is 1.2G plus 1.5Q. And now I need to choose dead load, and the multiplier or scale factor is 1.2, and I add it, and the other one is live load, 1.5 live load, and click OK. Add all your load patterns. For example, 1.2G plus wind load, WU. So we have 1.2G and 1 wind load. And we usually define the wind load as a plus minus WU, so you need to consider 1.2G plus, minus WU as well. What it does is it considers the WU as opposite direction. So it is what we normally do. However, if you are going to add your internal and external wind compression, wind pressure on your roof at the same time, it means you calculate the resultant of internal pressure and external pressure, that would make it wrong. So you cannot do that if you add those internal and external together and apply it here. So if you are applying in that way, just consider 1.2G plus WU. And also we have another load combination, which is 1.9G plus WU as well, which is 1.2G and 1, oh sorry, it's 0.9. 0.9. Okay, now we created our load combination. So the software will combine the loading itself for us. We are not worried about adding them together and applying on the structure. Now what we need to do is, I told you in the report to draw 3 diagrams, which is your truss with the dead load. So you have 3 trusses with 3 loadings. One of them is for dead load, one of them is for live load, and one of them is for wind load. And without any multipliers. So you have only G, only Q, and only wind load. So we are going to use those numbers here and apply them separately. We are not going to add them together because it is what software will do when it combines the actions. So don't worry about them and apply them as separate load. Now we want to apply our dead load here. So what we are going to do is to choose our joints that we want to apply the load on. So as I told you before, the end joint have less loading because the tributary area of the end joint is half of the others. So I'll choose the midpoint first, and I'll go to assign, joint load, and joint forces. When we are defining the load, so we can choose from here the load pattern once we apply the dead load, once we apply live load, and once we apply wind load separately. Pay attention to the direction of the axis. So here is your axis X, and here is Z. So for the dead load, we have to apply in the minus Z direction. So force global Z is, for example, because it's minus, you can also check the unit at the same time here to make sure the loading that you're applying is the same, and also here the units are available. So minus, let's say 1. I'm not going to do that. That would be a bit confusing, probably. 859, for example. It's just an example. And it is only the dead load. So I apply this, and you can see that the dead load has been applied on the correct direction. Again, you can choose the same joint and choose live load, put your live load here, whatever it is, it's just an example. So your live load, and again, apply. Here you can see your live load, which are applied at this joint. Maybe at this stage, you will get confused and say, where are my dead load? I just applied my dead load. I cannot see them anymore. The reason is the window only shows you one load pattern at a time. So if you have a look at the title of the window, you will see it is only the live load. It shows the live load. And again, I select them and I apply my wind load here, whatever it is. So if, because the wind load is perpendicular to the surface, you may apply the wind load in vertical direction and horizontal direction separately. So I just added the vertical one, but I realized, oh, I have horizontal one as well. So what should I do? I can add the horizontal one here as well, and I can replace it. So don't forget to select the joint, and then you can apply, then you can see you have all of them. Okay, you have to do the same for these end joints as well. Now, if you are not sure what loading you have applied on your members, you can easily just right click on each joint and go to load to see what loads you have applied. So you can see the dead load is minus 1.859, live load minus 1.118, and wind load in X direction is 0.855, and in Z direction minus 1.118. just an example. It is not a correct loading because for this joint, you have to apply the X load in the other direction because you want to get a perpendicular resultant. Here's just an example. Now, we are pretty much done. So by clicking on, before that, I have to mention that if you go to Analyze, Set Analyze option, make sure that your analyze will be done in XZ plane. So by clicking on this, it will choose the degree of freedom for you. So just click on this and say, okay, now the analyze will be done in 2-dimension, which is only a plane. Now we can run the model. It asks you where to save it. You have to create a new folder because when you run the software, it will create a lot of files and it will mess up with your files, a folder if you have any. So I'm going to name it like Sap model. And when I go to the folder, I write the date because you may run many or create many models and you don't want to just have a lot of models that you don't know which one was the recent one. So don't forget to put a date here for later on and save. After saving it, you see there is a deformation, which is normal. Any unrigid member will deform, and this is an exaggerated deformed shape of your truss. You don't need to be worried about that. So to see the results or the member loading, you can go to display and show force stress for frame. And we want to see, because you want to double check your hand calculation with this specific load combination. And you want to have a look at force. And you want to check the axial force. And here you can say, show me the values, because you want to see the values as well. By saying apply, you will see the values on your truss and you can compare each member loading with your hand calculation. And for the first thing that you can compare is the support reaction. So you can go to display, show table, and structure output, base reaction. And this base reaction is the total base reactions. And select all the load patterns, and you can just select one load combination that you're looking for and just say okay. So you can see in vertical direction the total load is 7.695, and yeah, so you can compare it with your hand calculation to make sure that it is correct. So it is in X direction and Z direction. when you say okay, it will just close it. What else? Okay. What I want you to bring to the class on Thursday is to add one more load combination. So if you just click on this to open the lock, because whenever you run the program, it will lock and it doesn't allow you to change it at all. You have to unlock the model first. Then go to define load combination and add new. What we want to do here, we name this envelope and choose envelope and add all of your load combinations that you created. What it does is to consider all of your combinations at the same time and choose the highest value or force for each member under any of these load combinations. So for design process, we need to consider the maximum force under any of these load combinations for each member. So when you say okay, now we have that load combination as well. If you run the model again and display load frame and choose envelope. When you choose envelope and make sure it is show on show value, you will see that you have the maximum value on each member. Here. This one, as you can see, this window hasn't changed. What I have done was on the other one. So again, I choose this and repeat what I've done again for envelope load combination. And now I can see for each member, for example, if I zoom on this member, you can see we have, if you right click, you can see it shows you that the axial force varies between these two values. So it shows the minimum and maximum on each member. And for example, for this one, minimum, maximum, and this one, as you can see, the minimum and maximum, one of them is positive, one of them is negative. So as you can see, one of them shows tensile force, one of them shows compressive force. For those members, you need to make sure that you design it for compression as well as tensile. However, those members which has only only compression, minus shows compression and positive tension. So if the minimum and maximum are both compressive, it means you only need to design it under compressive load, that we will discuss about it in the class. Or if it is tensile, you design it for tensile. So on Thursday, I want you to come to the class with this result and make sure that you have validated that load combination that you have the hand calculation for with the software. It should be reasonably close. And it can be a bit different, and it is because the software uses a finite element method, which means it breaks each element to like 1,000 parts and analyze it little by little. So because of that, it may not give you the exact number. So if as long as it is reasonably close to what you have, like 10 plus minus 10% difference would be acceptable. Then I want you to come to the class with these numbers that we will start designing the members for these courses. Thank you for watching this video. See you soon.